Well, the 211 was a quite an advanced engine concept, even by the standards of the day. It was the first three-shaft engine, whereas the competitors were offering two-shaft engines. So as well as the technological advances, it was a completely new architecture.
The design made the engine lighter and more efficient. It promised a crucial reduction in running costs and cheaper airfares. But actually building the engine proved harder than anyone expected, and the costs spiralled with every advance they made.
And all of these were put together in an engine number 10,011, which ran on February the 3rd, 1971, late in the afternoon. And the results were quite exceptional in that they were very much better than anything we'd run before. So understandably, we were quite elated.
It seemed the company was about to achieve its goal with their new engine, but the elation was short-lived.
Until the next day, when in the middle of the morning we were all invited to go into the office and the announcement was made that the company had gone into receivership.
It was too late. The project had bankrupted the company, and Derby was in crisis.
There's hardly a family in the town that hasn't got someone working at Rolls, not just as manual workers and skilled craftsmen, but as research workers and designers. When the men came out lunchtime, they were obviously shaken.
Shocked. Just shocked.
Looks very bleak. That's all I can say. I mean, looks very bleak, doesn't it?
Did you ever believe this could happen here?
Never. I've been here 27 years and I've never thought anything like this could happen.
I think the government ought to really back us up a little bit. Quite a lot, because it's a household name, isn't it, Royce's?
The government came to the rescue, saving thousands of jobs and giving Rolls-Royce and the people of Derby one last chance.
The progress that was made during the following 12 months, 14 months post the bankruptcy was quite remarkable. And we actually managed to get the engine into service at the end of April 1972.
When the TriStar finally flew, the hard work and revolutionary technology paid off. The engine became the jewel in Rolls-Royce's crown. And it still is today, as the basic design of the entire family of Trent jumbo jet engines. Launching Rolls-Royce onto the international stage, the engine helped them grow from a small player to a global competitor. Today, Trent engines are fitted to half the world's big passenger jets, with new orders worth over £40 billion. At the heart of the Derby factory is the main assembly line for all Trent engines. The line has to run like clockwork to take every build from first components to completed engine bang on schedule.
From the moment we launched the kit to make the first internal module right through to the engine being dispatched, it's 20 days.
The countdown starts with assembly of the biggest and most complex modules. Hundreds of precision-tooled blades, hand-fitted and finished to perfection. 4 days in, and work begins on the engine's Kevlar-wrapped aluminium fan case. Over 4,000 engine control and transmission parts, fitted and wired, every one by hand. At the same time, an army of expert fitters begin the 9-day task of fitting together the engine's 8 separate modules. The first 5 sections are stacked one on top of the other. With gravity helping the process, it's a lot easier to achieve a perfect fit. Every bolt is adjusted to a precise torque, and there are moments that require absolute concentration.
Going down. We're having to pass through the whole of the 04 module before we arrive at the coupling in the 03 module, and we take all the care we can not to touch the sides. If it ticks the paint off the shaft, then we have to recoat the paint for protection. It's the trickier of them all to fit, mainly because of the coupling that you can't see and the adjustment that's needed. Going down.
And there's the two shear keys that will ride up and locate in the slot. And you should hear as it clicks. They'd have clicked in now.
1 week into the build, the fan is assembled from its kit of blades. And with each one worth as much as a family car, it takes an expert touch.
We prefer to wear gloves. It keeps fingerprints off the blades and this grip as well. So it does stop them slipping out of your fingers.
You don't want to drop it, do you?
Certainly not. Certainly not.
Before the fan can be fitted, the towering engine stack is craned onto its side. Two tons of precious metal swinging just feet from the ground. Finally, in the position it'll spend the rest of its life, the engine's ready for the last two and biggest modules. The fan is a perfect fit. Its tips clear the lining of the case by a fraction of a millimetre, yet in flight will spin faster than the speed of sound. After 2 weeks of assembly, every completed engine is fitted with vast aerodynamic ducts and inched across to the factory's purpose-built flight test centre. Here, it'll be fired up and put through its paces in a simulation of the harshest flight conditions.
3, 2, 1.
While engineers monitor vibration, rotation speeds and temperatures to ensure everything performs perfectly.
Vibration is looking good. Max conditions now, hands down to point. 3, 2, 1, go.
Signing off newly built engines isn't all they do at the test centre. Dave Benbow is in charge of testing prototypes for new engine designs before they ever take to the sky. And that means carrying out tests that are much more challenging.
We run thousands of hours of testing. Our primary requirement is to show that the engine is safe to fly, that it's airworthy. We conduct a number of tests to do that, but really we're trying to meet the regulations of the safety agencies. This engine is a flight test engine, and in that extent it has a lot of instrumentation that production engines wouldn't have, that you can see here is led up off the engine and into the pylon so that we can record the data on the test bed when it's installed.
Testing is so exhaustive, it can take 2 years for each new design.
The cold start tests are